Transformer. Transformer is the device with the help of which we can increase or decrease the voltage. And we know this thing, in the transmission of electrical energy, the power loss takes place. So with the help of transformer, when we increase the voltage, and then after, if the transmission is carried out at high voltage and low current, then the transmission loss that can be minimized. Now this particular device, transformer, works on the principle of electromagnetic induction. Now its construction. So say, suppose as shown in this figure, sometimes this type of shape of the core, which one is made by soft iron, is taken. Or sometimes this type of rectangular or square iron core is taken. And now on this particular core, two coils are wounded in such a way that each and every turn of both the coils, that is insulated with respect to each other. One coil, that is called primary coil, to which the input supply is given, and another coil across which the output is taken, that is called secondary coil. Okay, so here, as shown in this first figure, we can take this red coil as primary and this blue coil as secondary coil. Here, as shown in the second figure, we can take this left hand side coil as primary one, and on right hand side the coil is a secondary coil. The circuit symbol for transformer, that is like this, as shown in this figure. Clear? Now suppose number of turns in the primary coil, that is NP, and number of turns in secondary coil, that is NS. Now if supply is given to this primary coil, means some current is passed through this primary coil, then the flux associated with this primary coil, that we can take total number of turns NP, and suppose the flux associated with each turn, that is phi, then we can write the total flux associated with this primary coil, that is NP into phi. But now if the supply given to this one is continuously changing, means AC supply, then flux associated with this primary coil, that is also changing one. So here across primary coil, the EMF, that is minus NP d phi by dt, that is also represented as Vp. Now when the current is flowing through this primary, the magnetic field is produced, and those magnetic field lines passes through these primary coils, but primary coil is wounded on the core of soft iron, and soft iron attracts the magnetic field lines, and therefore maximum magnetic field lines will pass through this one. But see, the same core is here for secondary also. So when those magnetic field lines are passing through this particular core, it implies that that magnetic field is passing through this secondary coil also. So here, if the flux is changing associated with primary coil, then flux will change associated with secondary coil also. And therefore, across two terminal of the secondary coil, the EMF obtained, that is ES, that is minus ns d phi by dt. Here ns, that is the number of turns associated with this secondary coil or in the secondary coil. That is also represented as Vs. So now from these equations we can write, if we take the ratio of these two, then Vs by Vp, that is Ns by Np, or we can write Vs equal to Vp into Ns by Np. Now see here, suppose input voltage here, that is 100. Vp is 100. And now number of turns in secondary is 100 turns and number of turns in primary, that is 10. So 100 by 10 here, if we substitute, then 100 into 100 by 10, so you will get resultant Vs, that is 1000 volt. Means input voltage given, that is 100 volt, and output voltage obtained, that is 1000 volt. And means here we can say if Ns by Np is greater than 1, then output voltage will be greater than input voltage. એટલે આપણે ઇનપુટમાં જે વોલ્ટેજ આપ્યા એને ટ્રાન્સફોર્મરે આઉટપુટમાં મોટા બનાવીને આપ્યા આપણને. એટલે આ ટાઈપનું જે ટ્રાન્સફોર્મર હોય, that is called step up transformer. And the transformer for which Ns by Np is less than 1. So in that particular case, the output voltage that will be less than input voltage. So that is called step down transformer. Now, if we think about the ideal transformer, then for ideal transformer, input energy, that is equal to output energy. So input energy, so input supply Vp, input current Ip, then we can write Vp-Ip. That is equal to output voltage Vs. Suppose output current is Is, then that is Vs-Is. So Vs by Vp, that is Ip by Is, that is Ns by Np. Means here you can understand, if voltage in output increases, then current decreases, but the power that remains the same. Power that remains same one. Clear to all of you? Any doubt in this one? Idealistic situation. Now in idealistic situation means for ideal transformer, input energy, that is equal to output energy, or we can say input power, that is equal to output power. But in practice, always there is the dissipation of energy in the form of heat. Okay, and now in different ways the energy loss takes place in transformer. Say in practice, what happens, the energy loss occurs due to different reasons. For one, that is a flux leakage. So here there is always some flux leakage, that is not all of the flux due to primary passes through the secondary. Due to poor design of the core or the air gap in the core, it can be reduced by winding the primary and secondary coil one over the other. So this one design is good compared to this one. Then second thing, resistance of the windings. The wire used for the winding has some resistance, and so energy is lost due to heat produced in the wire I square R. In high current, low voltage windings, these are minimized by using thick wire. So for these windings, some resistance is there. And in third chapter, we studied this thing, resistance R, that is rho L by A. So if cross-sectional area of the wire is more, means for thick wire, the resistance is less. So now we have to use thick wires for the winding of the transformer. Then eddy currents. The alternating magnetic flux induces eddy currents in the iron core and causes heating. The effect is reduced by having a laminated cores. So this core part, which one is made by soft iron, right? That we have to use in the form of very thin laminated plates, and by joining them we have to make this thick core part. Okay, so the effect of eddy currents can be reduced. Then after hysteresis, so the magnetization of the core is repeatedly reversed by the alternating magnetic field. The resulting expenditure of energy in the core appears as heat and is kept to a minimum by using a magnetic material which has a low hysteresis loss. So here, when the current is continuously changing directions, positive, negative, positive, negative, positive, negative, half cycles are appearing at a terminal of primary. So when current is continuously changing its direction, then magnetic field produced in this one is also continuously changing one. And therefore, the magnetization and demagnetization of the core part take place. So for that, hysteresis loop will be formed. And now, and in the magnetization and demagnetization of the substance, we already discussed this hysteresis loop, and we discussed this thing. The area of the hysteresis loop give you the loss of energy in the form of heat. So here, as a core of this transformer, we have to use such a material for which the hysteresis loss is minimum. So now using these transformers, the long distance transmission is carried out. So when we transmit the energy at that time, we use step up transformer, which increase the voltage and decrease the current. And when the electrical energy reaches to the end user, then step down transformer will give you the original form of electrical energy, means it will give you the required voltage and required current to the end user. To minimize this transmission loss, this one is very, very, very useful. So now the chapter is complete.